Hello everyone. So here I'm going to walk you through an ANOVA hypothesis test example. A human factors psychologist studied 3 computer keyboard designs. 3 samples of individuals were given material to type on a particular keyboard, and the number of errors committed by each participant was recorded. The data are as follows. So here is the data for 5 individuals for keyboard A, the data for 5 individuals for keyboard B, and the data for 5 individuals for keyboard C. Now, in this little table, I've gone ahead and I did most of the calculations for you so you don't have to do them yourselves. So the the treatment total, right? T1 for keyboard A is equal to 5. I just added these up, right? 4 plus 1 is 5. Treatment total for group 2 is 25. So adding these scores is equal to 25. And then keyboard C, adding these scores, this is treatment total 3, is equal to 30. Now, in order for me to get grand total, remember it's the sum of T1 plus T2 plus T3, which is equal to 60, right? And I went ahead and squared all these and then added them all up, and I got a sigma x squared equal to 356. So that's given. You don't have to redo it yourself, okay? And I've calculated SS1, which is equal to 12. So this is sum of squares within, right? So this is sum of squares within for group 1 is 12. Sum of squares within for group 2 is equal to 20. And sum of squares for group 3 within is equal to 14. So the question is, are these data sufficient to conclude that there are significant differences in typing performance among the 3 keyboard designs? Conduct the appropriate hypothesis test using alpha equal to 0.05. Make sure to state your conclusions in terms of the problem and use APA format. All right, so step 1 is to state the hypotheses. So the null hypothesis, which is right here, is that mu1 is equal to mu2, which is equal to mu3. So the type of keyboard used has no effect. The alternative hypothesis, which is right here, is that at least one mean is different. Okay, so we don't know where the difference is going to be, but we're going to say that at least one of the means is different from the others. Okay? Step 2 is to set criteria and locate the critical region. So alpha is equal to 0.05, and we're going to have to calculate degrees of freedom for between groups and degrees of freedom for within groups in order for us to come up with the degrees of freedom to look up the F critical value in the table, right? So between groups, so degrees of freedom between groups is equal to the number of groups minus 1. So we know that there are 3 groups minus 1. So degrees of freedom between groups is equal to 2. Degrees of freedom within group is equal to total number of observations minus the number of groups. So n minus k, which is equal to 15, right? 5 people in 3 groups, 5 times 3 is equal to 15, minus 3 groups. So our degrees of freedom within is 12, right? So we need to look up a critical value for 2 degrees of freedom and 12 degrees of freedom. All right, so let me go ahead and pull that table up. All right, so here's the table from the top hat appendices, right? So it's the critical values of F for the 0.05 significance level. This up here is for the between group, degrees of freedom between group, right? So each column represents the degrees of freedom between groups, right? So it's between groups is 2. So we're going to look down this column here. And the rows represents the degrees of freedom within groups, okay? So we're going to look for row 12, column 2. So here is the F critical value for 2 degrees of freedom between groups and 12 degrees of freedom within group. So our F critical value is equal to 3.89. So this is the value that we're going to need to beat. All right, so step 3, calculate the test statistic. So we're going to divide this up into 4. So we're going to go with step 3A. And the first thing I always recommend is to calculate the degrees of freedom because they're easy and quick to do, right? So we've already done the degrees of freedom for between group and within group, right? So we've got degrees of freedom between group equal to 2, degrees of freedom within group equal to 12. Now we just need to calculate degrees of freedom total, which is the total number of scores, n minus 1, 15 minus 1, which is equal to 14. Step 3b is to calculate the sum of squares. So first start with calculating the sum of squares total, right? So the sum of squares total is our sigma x squared minus our grand total squared divided by n, right? So recall that x squared, the sigma x squared, is equal to 356 minus grand total of 60 squared divided by 15. So 356 minus 3600 divided by 15 is equal to 356 minus 240, which is equal to 116. That is our sum of squares total, right? Now we need to divide that, partition it out between the sum of squares within and the sum of squares between. Sum of squares within is really simple. It's just sum up the sum of squares within each group, which was 12 plus 40 plus 14, gives us a sum of squares within group of 46. Now you don't need to do that complicated formula for sum of squares between groups because sum of squares total is equal to sum of squares between groups plus sum of squares within. So we can actually calculate sum of squares between groups by just taking sum of square total minus sum of squares within group. So that's 116 minus 46, which gives us a sum of squares between groups equal to 70. That brings us to step 3C, which is to calculate the mean squares. So now we need to figure out what are the variances between and what are the variances within. So our mean square between group is equal to sum of squares between group divided by its degrees of freedom, which is equal to 70 divided by 2, which is equal to 35. Our mean square within group is equal to sum of squares within group divided by its corresponding degrees of freedom, which is equal to 46 divided by 12, which is equal to 3.83. Phew. So here's step 3D, which is to actually calculate the test statistic. We finally arrived, right? So our F ratio is equal to our mean square between group divided by our mean square within group, which is equal to 35 divided by 3.83, which is equal to 9.14, which if you remember our F critical value was 3.89. We beat it, right? So we got to calculate an effect size. Eta squared is equal to sum of squares between group divided by sum of squares total. So it's equal to 70 divided by 116, which gives us an eta squared of 0.60. Now, I want to show you how this all fits into the ANOVA table real quick, because it's really easy to just plug all these numbers into the ANOVA table, right? So it's a summary table, which helps you to just see everything visually. So here are the sources of variability between, within, and total, right? Here's the sum of squares. Here's the degrees of freedom. Here's the variance or the mean squared, the F statistic, and the P, right? So we just plug in sum of squares between, which was 70, sum of squares within, which was 46, sum of squares total, which was 116. When you add 70 and 46, it should equal to 116. Degrees of freedom between was 2. Degrees of freedom within was 12. Degrees of freedom 14. Degrees of freedom total was equal to 14. When you add these two together, 2 plus 12 should equal 14. With me so far? Good. So now mean square, right? So now we take sum of squares, 70 divided by degrees of freedom 2 should give us 35, right? Mean square within is we take our sum of squares within, 46 divided by degrees of freedom within of 12 gives us a mean square within of 3.83. Now we calculate our F. We take 35 divided by 3.83, and that gives us 9.14. And we know that this F, comparing it to the critical value of 3.89, beats it, so it's a probability of less than 0.05, right? So step 4 is to make the decision. The obtained F with 2 and 12 degrees of freedom is equal to 9.14, which is greater than F critical of 2 and 12, equal to 3.89, I think it was. Whoops, there we go, 3.89. So our decision is to reject the null hypothesis. So here is how we write this up in APA format. Reject the null. The analysis of variance indicates that there are significant differences in typing performance among the 3 types of keyboards. F, and remember it's comma, and then we have to provide our statistics or a statistical evidence to back up the claim that we just made, right? So F with 2 and 12 degrees of freedom is equal to 9.14, comma, P less than 0.05, comma, eta squared equal to 0.60, period. The type of keyboard used has a significant effect on the number of errors committed. So there you go. We just did our first hypothesis test.